Hi again, everybody. This is Unit 5, Lesson 3. It's on solving absolute value equations. I'm going to call mine answer key. And we'll start off with the definition of absolute value. And it says if a number is positive or zero, its absolute value is the number itself. So, for example, if you have a positive number and you do the absolute value of 3, it's just the number itself, and the absolute value of 0 is 0. Okay, and of course, absolute value is depicted by those vertical bars, like this. Okay. If a number is negative, its absolute value is the opposite number. So, for example, the absolute value of negative 2 is just 2. Okay, so basically, a positive comes out of an absolute value. And you can kind of think of the absolute value function as the distance that a number is away from 0. So for example, if 0 is here and we wanted to know the absolute value of 3, well, 3 is over here, and you notice that that's a distance of 3 units to the right. Okay, and similarly, if you wanted to know the absolute value of negative 3, the distance that negative 3 is away from 0, that's still 3 units, right? It's still 3 units, 1, 2, 3, just in the opposite direction. Okay, so you can kind of think of it as a distance. The technical mathematical definition of absolute value looks like this. The absolute value of x is equal to just itself x if x is greater than or equal to 0, and it's equal to the negative of x if x itself is already negative, if x is less than 0. Okay, so what does that mean? So for the top case, if x is greater than or equal to 0, let's choose 2, that's greater than or equal to 0. The absolute value of 2 is just itself. If x is less than 0, let's choose negative 2, and we do the absolute value of negative 2. It says you're supposed to take the negative of that x value. So it's like you're doing the negative of negative 2, which makes it positive. Okay, so that's why the technical definition is written as shown there. An equation containing the variable or unknown inside an absolute value sign is called an absolute value equation. And for example, it looks like this. The absolute value of x minus 2 is equal to 5. This is an absolute value equation. And to solve an absolute value equation algebraically, we can follow these steps. You use the definition of absolute value. This means that 2 separate cases must be considered corresponding to the 2 parts of the definition. So if you look at the definition, the absolute value has 2 parts, like the positive x comes out and the negative x comes out in certain situations. Okay, so basically we're going to set up 2 equations. Step 2, we are going to identify extraneous roots and reject them. Alright, so let's try example 1. Solve for x. The absolute value of x minus 2 equals 5. What is the solution to an equation like this? Okay. So, since the x minus 2 is in absolute value bars, guys, we have two situations that can happen. If the x minus 2 worked out to 5, we would get the absolute value of 5 is 5, and that works. But inside the absolute value bars could also work out to negative 5. Okay, and the reason for that is the absolute value of 5 is 5, but the absolute value of negative 5 is also 5. Okay, and so we end up getting these two equations that we can make, and it looks like this. X minus 2 could work out to 5, okay, because the absolute value of 5 will equal 5. And the other equation is that the x minus 2 could work out to negative 5. And then when you absolute value that, you'll get 5 as well. So you end up getting two little equations that you can solve. And you add 2 to both sides. X equals 5 plus 2 is 7. Add 2 to both sides. X is equal to negative 5 plus 2, which is negative 3. And we get two answers. But we need to check these to make sure we don't have any extraneous roots. Okay, so let's check the 7. The original equation is absolute value of x minus 2 equals 5. And we're going to take the 7 and plug it right there. Let's do our little barrier. And we will go the absolute value of 7 minus 2, which would work out to the absolute value of 5. And the absolute value of 5 is 5. So that works. That's a good answer. And now let's check x equals negative 3. Barrier. So we are going to take negative 3 and plug it there. So we have the absolute value of negative 3 minus 2, which is the absolute value of negative 5, and the absolute value of negative 5 is 5. So that works as well. Both of our answers work, so they are good. Okay, and if you want to see a picture of what this means, if we did the graph, we will graph absolute value of x minus 2, and we will also graph y equals 5, and we want to know, hey, where are these two functions equal to each other? Where does the absolute value of x minus 2 equal 5? So there's the absolute value graph. We know that's a v graph, and y equals 5 is a horizontal line. I'm just going to standardize the window here so we get a better view. There's the absolute value graph. Hey, there's y equals 5. There's two crossing points, two solutions at negative 3 and 7. So if we were to calculate an intersection point, first curve is the absolute value, second curve is the straight line, and then we're going to guess that it's right there. Negative 3 comma 5, and we got that x value of negative 3. Good. Let's go find the other intersection point. First curve is the straight line, the second curve is the absolute value, and I'm going to guess that it's right about there. Intersection at x equals 7. Okay, so that's what's happening graphically, and if you want to try these graphically, I would always encourage you to look at Desmos. Okay, let's try example 2. Solve and check. How about the absolute value of 4x minus 1 equals x? And we're going to use the same principle as before. Two equations come out, right? 4x minus 1 could just work out to x, and the absolute value of a positive stays the same. The other equation is the 4x minus 1 could work out to the negative of x. Okay, so it could work out to the negative of x, and then when you absolute value it, it will equal x. So there's the two equations. Solve these separately. Yeah, let's subtract 4x from both sides. We get negative 1 equals negative 3x. Divide by negative 3. Divide by negative 3. And we are getting one possible answer of negative 1 over negative 3, which is 1/3. And now let's solve the other one. Subtract 4x, subtract 4x. We end up with negative 1 equals negative 5x. Divide by negative 5, divide by negative 5. And we get x equals negative 1 over negative 5, which is 1/5. Okay, so two possible answers again, and we will check. The original equation is the absolute value of 4x minus 1 equals x, and so you have to plug 1/3 in here and 1/3 in here. So we would get the absolute value of 4 times 1/3 minus 1. Does that equal 1/3? Okay, and then you put a barrier down the equal sign, and you have to see if the left-hand side works out to the right-hand side. Okay, and so we could use the calculator and we could go math, and there's a few menus up there. Notice there's this one called number, and then there's ABS, absolute value. So I could put absolute value, and in my absolute value I have to have 4 times 1/3 minus 1, and then close the absolute value bars. We want to know if that's going to equal 1/3. Press enter, I get 0.3 repeating. If I go math, and notice in math there's that fraction 1, so press enter on it, enter again. Hey, I get 1/3. So this is 1/3. It works out to that side. That's a good answer. Okay, now does 1/5 work? The original equation is absolute value of 4x minus 1 equals x. I'm going to put 1/5 here and 1/5 here. So it will be 4 times 1/5 minus 1, the absolute value of all of that. Does that equal 1/5? Bang. Math. Go over to number. Absolute value. 4 times 1/5 minus 1. Close the absolute value bars. Does that equal 1/5? 0.2. Math. Fraction that. Hey, it's 1/5 as well. Okay, so 1/5 is a good answer as well. Okay, so we didn't have to reject any extraneous roots, but that's always a possibility, so that's why we have to check our answers. This assignment is good, except I'm going to axe 5 and 6. So let's get rid of 5 and 6. Let's just say 1, 3, 7, 10, 12 all. So there's your homework. It's on a photocopied sheet, so I'll send that in email as well. And I will send this to you. Should get this on next Monday. I guess that's going to be April 20th. And then near the end of the week, I will send you some homework solutions. All right. Talk to you soon.